Welcome to Anatomy and Physiology Online Education. In our latest installment, we look at the classification and function of joints or articulations. A number of different organ systems make up the human body. Today we're going to be focusing on the skeletal system. Now the skeletal system consists of 206 bones divided into two sections. The first section, represented in green here, is called the axial skeleton, which consists of 80 bones. The second section is called the appendicular skeleton, and it consists of 126 bones. Now where each of these bones meet, we have what's called a joint or articulation. Now if I ask you to think of a joint, most of you will straight away have thought of something like a knee, maybe an elbow or a shoulder. There's not many of you that would have actually thought about the joints that occur in something like the skull. So there's many joints found throughout all the body. What we have to learn today is how do we classify each of these joints. So a joint can be classified by either the structure or the function of the joint. The structure focuses on the materials that bind the joint together, whilst the function of the joint focuses on the amount of movement that is allowed at the joint. Now there's three different structural classifications. The first is called a fibrous structural classification. And now a fibrous joint, as with all fibrous joints, are joined by fibers, and there's three different types of fibrous joints. The first type is called a suture joint, which means short fibers. So if we have a look at this picture below, we can see an example of a suture joint which occurs in the skull. So the fibers are so short it just looks like the bones fused together like seams across the top of our head. Now when we think about the mobility of this joint, there's three different ways we could classify mobility. The first way is called a synarthrotic, which means no movement. So when we think about it, this is easy to remember because the fibers in this case are so short, they're fused together, meaning there's not a lot of movement between them. In this case, there's no movement between them. The second type of fibrous joint is called a syndesmosis joint, which means long fibers. And the example we've got here is the distal tibiofibular joint, which is a small ligament which joins the tibia and the fibula together in our lower leg. Now the type of mobility class of this joint is called an amphiarthrotic, because that means slightly movable. So unlike before we had the short fibers where there was no movement between them, the slightly longer fibers allow for a little bit of give. So they still can't bend and flex like the way we typically think of joints, but they're just a little bit flexible. The third type of fibrous joint is characterized as a gumphosis joint, which means peg in socket. And the example here we've got in the picture is the only example that we have in the human body, which is a tooth fitting in or joining into the gums. And when we think about a tooth, we think, well, there's no movement, they don't bend or flex, or they're not flexible at all, so they too are characterized as synarthrotic, meaning no movement. So the second type of structural classification is called a cartilaginous structural classification. There's two different types of cartilaginous joints. This first is called a synchondrosis joint, which refers to cartilaginous joints that are joined via hyaline cartilage. So the examples we see in the pictures below are the join between the diaphysis and the epiphysis of a long bone, so at the epiphyseal line, and also between our first rib and our sternum. Now, cartilaginous joint, it's almost as hard or hard like bone. So if we think about our shaft and the head of a long bone, we know that there's no movement there, so they're classified as synarthrotic, or no movement. The second type of cartilaginous joint is called a symphysis joint, which refers to cartilaginous joints that are joined via fibrocartilage. Now in comparison to our synchondrosis joints, they have a little bit more give, a little bit more movement. So they're classified as amphiarthrotic in mobility, meaning slightly movable, a little bit of give. The two examples we've got here below are our intervertebral discs and our pubic symphysis. The third type of structural classification is a synovial classification, and these are joints that are characterized as joints which are separated by a fluid containing joint cavity. Now there's 6 different types of synovial joints. The first type is called a plane joint. So we can see up in the picture an example of a plane joint which occurs at the intercarpal joints. But all plane joints are joints which are 2 flat surfaces which rub up against each other. So not one part is fitting inside another part, it's just 2 parts lying flush or next to each other. Now the mobility classification of the plane joint is a diarthrotic, which is our third type of mobility, which means freely movable. And it's important to note at this point that all synovial joints are characterized as being diarthrotic or freely movable. The second type of synovial joint is called a hinge joint, and the example we've got up here in the picture is the elbow. But all hinge joints are classified as a bone or part of a bone which wraps around a cylinder type shape of another bone. The third type of synovial joint is a pivot joint. Pivot joints all look like a spherical bone which has a part of a ligament or a ligament which wraps around the head of the cylinder, allowing this pivot type action. The example we've got here in the picture is the proximal radial ulnar joint occurring in the forearm. The fourth type of synovial joint is called a condyloid joint, and the example we've got up here in the picture is the joint found between the metacarpals and the phalanges in our hand or fingers. Now all condyloid joints look kind of similar to a ball and socket joint, but rather than being a circle, it's an oval, so it's kind of like an oval shaped ball and socket joint. The fifth type of synovial joint is called a saddle joint, and a saddle joint occurs, an example we've got is at the thumb. And what a saddle joint looks like is a convex and a concave shape joint together or fitting together. The sixth type of synovial joint is called a ball and socket joint. And this is where we've got a round or spherical head on a bone fitting inside an opposing spherical basin type structure on an opposing bone. So the final stage of joint classification is the axis of rotation. So this describes how many axes the joints rotate around. So when we're talking about fibrous or cartilaginous joints, where the mobility is synarthrotic, meaning no movement, or amphiarthrotic, meaning slight movement or a bit of give, the axis of rotation is non-applicable because they're not rotating around any axes. So this particular focus of axis of rotation is on the synovial joints because they're all diarthrotic or freely movable. So the first type of axis of rotation is called a non-axial, which means no axis or rotating around no axis. And these are examples here of all our plane joints. So they're diarthrotic, they're freely movable, but they don't rotate around any particular axis. The second type of axis of rotation is called a uniaxial joint, or a uni meaning singular axis. So it's rotating around one axis. And examples of uniaxial joints are both hinge and pivot joints. So if we were taking, say, the elbow as an example of our hinge joint, it can only flex and extend, so it's rotating around one axis. An example of the radial ulnar joint as a pivot joint, it can only pronate and supinate. Now the next type of axis of rotation is called a biaxial joint, which refers to rotating on two axes. And the example we've got above here is both a condyloid and a saddle joint. So in both of these examples, these joints are able to flex and extend. They're also able to abduct and adduct, or a combination of these movement terms, which is circumduction, but they're not able to rotate. And the final axis of rotation is called a multi-axial joint. These joints are able to rotate on all three axes. So a ball and socket joint is able to flex and extend, abduct and adduct, and also circumduct as a combination of these, but it's also able to rotate. So now that we have all the information, when asked to classify a joint, we must make reference to each of the following sections: structural class, types, mobility, and axis of rotation. So when dealing with fibrous and cartilaginous joints, we only need to worry about the first three different sections, so structural class, types, and mobility. However, when we're talking about a synovial joint, we must remember the fourth type. So it'd be structural class, types, mobility, and also the axis of rotation. So let's use an example. If you were asked to classify the distal tibiofibular joint, it would be a fibrous, syndesmosis, amphiarthrotic joint. So three things to remember there because it's a fibrous joint. If we looked at the pubic symphysis, it would be classified as a cartilaginous, a symphysis, amphiarthrotic joint. But if we were to give an example of a synovial joint like the shoulder, it would be classified as a synovial, ball and socket, diarthrotic, multiaxial.